So we've talked about how to look at the relationship between two numeric variables. But what if one of the variables you're interested in looking at the relationship of is categorical? So we need methods to look at the relationship between a categorical variable and a numeric variable. So I'll show you two different ways to do that here. So on my screen here I have code to create what we call a box plot. And a box plot is a way to summarize the distribution of a numeric variable. But the nice thing is you can arrange box plots by categories of a categorical variable. So I have a long list of categorical variables here: fuel type, aspiration, number of doors, etc. And we're not going to look at all those plots in detail, but we're going to use Seaborn, again, on a white grid, and we're going to use the box plot method. And you see the column is going to be the categorical column, and the Y column is going to be price. So on the vertical axis we'll have price, and it's going to be effectively a group by the categories of the categorical column. And of course we have our labels as always, so we know what we're looking at. So let's look at our first box plot here, which is, you can see there's a categorical variable called fuel type, and it has two categories, gas and diesel. And here's the price of the automobiles. So how do you understand what's in this box plot? It's kind of a funny looking thing if you've never seen one before. Well, first off, the box, which is why it's called a box plot, contains the inner two quartiles of the data. So there's half the data values are within the box. So that's the 25% quartile, and that's the 75% quartile across the top. And the same here, 25%, 75%. And then there's this dark line in here, and that is the median, or 50% quartile. Okay, so right away you see the center of the distribution quite well. And there are these things which are called the whiskers. So the rule for the whiskers are they're as long as the most extreme value, or 1.5 times this inner quartile range. We call this the inner quartile range between these two middle quartiles. So down here, there aren't any cars cheaper than 5,000, so that just cuts the whisker at whatever the lowest value is. This is 1.5 times that. And then you see, or roughly is, and then you see these outliers are shown as little diamond shapes because they're outside this normal range here. And that's why we consider them outliers on the box plot. And you see a similar thing here. But it looks like for the diesel cars, there aren't any real outliers. Everything is within 1.5 times this inner quartile range. And so the question is, well, what do you get out of this plot? One thing, you can get a quick view of how much overlap there is between these two distributions. So you can see that most of the bulk of the gas cars, half the values have to be below the median or down here. They're actually down in the price range of maybe about 1/4 of the diesel cars. And a lot of diesel cars are more expensive. So generally you'd say gas cars look a little cheaper, but it's not a stunning difference. We can get a similar for, say, standard versus turbo aspiration. Again, we have a new categorical variable, aspiration, and you have the standard and the turbo cars. And you can see standard cars, first off, they have a much wider range of values. The median is much lower. So there is some difference, but then there's these very expensive cars that seem to all be standard with just one kind of turbo outlier there. So that tells you quite a bit about breaking down those distributions of that. So let's scroll down to something a little more complicated here, like say engine type. Does that matter? And so that now you start to see if you have a lot of categories in a categorical variable, and even in this case, we only have 5, but it still starts to get pretty complicated. And trying to compare those distributions with maybe histograms or kernel density estimate plots becomes difficult. But if you lay box plots side by side like this, it's pretty easy. For example, the OHCF engine type is clearly on average the cheapest, and the OHCV are all more expensive than that one. So you'd also have to look at the frequencies to see, is this a common engine type or is that a common engine type? But you start to see there's considerable separation in price by engine type for certain categories. And finally, number of cylinders. So we have a very cheap car with 3 cylinders. We have a fairly expensive car with 12 cylinders. We have a bunch of 8-cylinder cars that are quite expensive. And so you start looking at this and you start thinking, well, maybe we should really lump the one 12-cylinder car, which it's hard to get any meaningful statistics out of one sample. Maybe we should lump that with the 8-cylinder cars. Maybe we should lump the 6- and 5-cylinder cars together because they clearly have different behavior from the 4-cylinder car, and maybe this 3-cylinder car should go in there. So we might, looking at these box plots, you get ideas of how to do a little bit of what we'll talk about later as feature engineering. So there's one other way to do this, which is a violin plot. And it's easier just to create the plot and we'll talk about it. Okay, so this is a violin plot of fuel type, gas, diesel, and price. And what this is this is a kernel density estimation plot. This is a kernel density estimation, I should say curve. This is, and this is. So now you're looking at the KDEs for gas cars versus price, and diesel cars versus price. Notice that there's a box plot in here. The little white dot is the median. You can see the box and you can see the whiskers. They don't show you the outliers because those show up in like the neck of the violin, or the, if you want to call it that. So, and again, you get a better feel for, in many ways, just like the difference between a histogram and a KDE, there's the difference between a box plot and a violin plot. And I really like the violin plots. You can see quite a bit of interesting structure in differences this way. And one thing to keep in mind, the area under each of these curves is the same. So if you get situations like this, which is number of doors, well, actually, let's not look at that. How about this? Body style. You see hardtop, well, it looks like it just has a wide price range, but the area under that curve, each half, remember you're looking at 2 curves back to back here. The area under that curve has to be the same as, say, hatchbacks. Hatchbacks have a pretty narrow price range, so they look kind of peaky, whereas hardtops are very diffuse in price, so they're very stretched out. But the area under those curves are the same. And if we go down to our example of number of cylinders, again, you can start to see what I was talking about. If you want to lump some of these categories as a feature engineering process, it is also evident how you might want to do that. So that's 2 different ways we can look at the relationship between categorical variables and numeric variables using box plots or violin plots. And they show you different things, and they're both very useful.